good afternoon, and welcome everyone to today's Southern Fire Exchange webinar. My name is David Godwin, and I'm the director of the Southern Fire Exchange program with the University of Florida. Today I'm excited to introduce our guest speaker, Dr. Dave Coyle with Clemson University. And over the next hour, Dave will be talking about the work that he and his colleagues have been doing regarding the use of prescribed fire as a management tool following drought events in the Southeast. And I'd like to also go ahead and express a welcome to our other panelists who should be joining us for the Q&A session at the end of Dave's presentation. Leslie Bobby, Joel O'Brien, and Doug Aubrey. So thanks you guys for joining us. Looking forward to having you part of the conversation later on. I would like to take just a moment here to share a little bit of information about our program, the Southern Fire Exchange. SFE is a regional program for fire science delivery in the Southeast. We are a collaborative among the University of Florida, Tall Timbers Research Station, NC State University, and the U.S. Forest Service Southern Research Station. We work to develop programs, opportunities, and events that bridge the divide between the fire science and wildland fire and natural resource management communities in the Southeast, so that land management outcomes improve and society can more safely live with wildland fire. Throughout the South, we host workshops, we coordinate webinars like this one, we develop fact sheets, and create other content to move science into the hands of managers. And we also work to connect researchers with the needs and pressing demands of the management community, so that if they're interested in doing applied fire science research, they are connected with folks in the management community. The best way to stay connected with us and to receive notifications about our upcoming webinars, field tours, and events is to join our email list, which you can do at our website at southernfireexchange.org, or you can connect with us on Facebook or Twitter. And finally, if you're joining us today from an area outside of the Southeastern U.S., first of all, thanks for joining us. It's pretty great. But please look into connecting with your local JFSP Fire Science Exchange network. So check out the map there, and you can see cover all of the U.S., including Alaska and Hawaii. And these are the folks that are working to connect regional managers and researchers to address local fire science issues and make a difference on the ground. So you can visit firescience.gov there for more information. And so now it's my pleasure to introduce our speaker today, Dr. Dave Coyle. Dave joined Clemson faculty in 2018 with a focus on forest health and invasive species extension. Prior to Clemson, he created and directed the Southern Forest Health and Invasive Species Program, which provided education and training to forestry professionals across the Southeastern U.S. Dr. Coyle uses various forms of communication, including social media, traditional writing, and in-person visits, to help educate people about forest health, invasive species, and forest management. He's a member of the Society of American Foresters, the Entomological Society of America, serves on the board of directors of the North American Invasive Species Management Association, and is the co-director of ProForest, an organization working to promote proactive forest pest management. So welcome, Dave. Thanks for joining us today. Thanks again to all our panelists, and I'm happy to have you with us in 1 sec as we swap out for your presentation.
All right, thanks, David. Are we all set?
Looking good, thanks.
Excellent, thanks everybody for joining us today. Today we hope to convey to you that fire is not something to be feared. I think everyone on here probably believes that. I hope if you're in the joint fire science realm, but this is what we're going to talk about, is don't fear the fire. And I've got a great group of collaborators and co-authors, Dr. Joe O'Brien and Mr. Ben Hornsby, Ms. Leslie Bobby, and Dr. Doug Aubrey. I believe Joe, Leslie, and Doug are online and can be here for the Q&A session at the end. So feel free to reach out, as David said, with any questions. Doug is a tree physiologist. Leslie has done a lot of fire work, and Joe's a fire scientist. So we could probably handle most of the questions that come in. Before we started, I wanted to just let you know that there is this publication available online, Introduction to Prescribed Fire in Southern Ecosystems. And there's a website right there, and I think David will push that out to you. This is freely available for download, and I think if you you may be able to get a hard copy at one of the local Forest Service offices depending on what their stocks are. But this is a great guide to talk about prescribed fire in southern systems. So, as the great Yogi Berra said, if you don't know where you're going, you might wind up someplace else. So, this is where we are going today. We're going to talk about fire-adapted ecosystems. Going to talk a little bit about prescribed fire and drought, and then bark beetles. And most of what we're going to talk about is how do we build resistance in forest systems in the Southeast using management tactics and thinking about bark beetles and the weather and the focus of that particular stand. So let's start with fire adapted ecosystems. Let's talk about it. So I have here fire as an imperative. This is a map published a few years ago where these scientists took quite a bit of data and did some modeling. And the main thing you need to look at is down here in the Southeast, let me get my pointer, down here in the Southeast, there is a burn interval of 2 to 4 years. So historically, this part of the world burned fairly frequently, and that comes from the type of vegetation we have, the type of weather we have, all of that stuff factors in there. And when you look at what a lot of our southern forest looks like, the form follows function. So they look a particular way because they are adapted to have fire going through them. And it's not just southern forests. You can look at all sorts of forests. This is 6 different forest types from around North America. You can feel free to guess on your own. This will not be a graded quiz, but name that pine. I have 6 of them here. And I'll just give you the answers. Up here we have ponderosa pine out west. We have slash pine, longleaf, shortleaf, loblolly, and pitch. And if you look at these pictures, all of them roughly look the same. Structure-wise, you've got a grassy-ish understory, you've got tall pines, you've got fairly good spacing. All of these forest types and all of these tree species are adapted to have fire go through them. So this is what a fire-adapted ecosystem is. It's a forest type, an ecosystem that is used to having fire and is co-evolved with fire. So when you put fire in it, everything is happy. So now let's touch a little bit on prescribed fire and drought. Which should be obvious is in the southeastern US, we do a lot of prescribed fires. Prescribed fire is one of our main forest management tools. We use it alongside thinning and herbicides, just like everything else. We have a lot of private land in the southeast as well. You get out here into the western part of the states, and most of the land is going to be federally owned, which can make it more challenging to do some of these management tactics. But down here in the southeast, I believe we're at about 87% privately owned forest land. It makes it a lot easier because that means every person that owns some of that land can decide what to do on it, and you get sort of you cut through some of the red tape, so to speak. But there are a lot of things that limit prescribed fire use. Everything from liability to capacity to having the resources to do it, public perception, but by far the biggest one is the weather. Weather limits fire use, and this should come as no surprise, as that is kind of our number one thing that limits what we can do. And I got this in that previous slide off a very recent National Prescribed Fire Use Survey report. There's also a link that I think David can push out if you'd like to take a look. There's it's about a 30-page document with a lot of great information in there. So here's what we know so far about our weather or our climate. Overall, rainfall is becoming more variable. Now these data are observed changes in precipitation from 1901 to 2007. So this is what's actually happened so far. These are not predictions. We've had deeper summer droughts and heavier rain events. We've had fewer light to medium rainfall events in the dry summer, and we've had an increase in frequency in heavy rainfall in wet summers. What that basically means is we are getting roughly the same amount of water, but it's coming in much bigger, faster chunks. Whereas in the past, you used to get a lot of fairly evenly spaced, fairly even amounts of rainfall coming down. Now we're getting big storms dumping 2, 3, 4 inches on us, and then it dries out for 4 weeks. And then we get dumped on again for 2, 3 inches, and then it dries out for 3 weeks. So there's a lot more variability to when we get that water, and as far as when we get it, and as well as how much we get at one time. This causes what we call flash droughts that sort of come out of nowhere and all of a sudden it's droughty, and it also causes flash floods, so a lot of flashing, if you will. Now, this is what's happened. This is our observed stuff. If we go ahead and look and see what do the models predict going forward, all these little pictures of the USA is more of the same. You've got a similar pattern, but intensified. And even if you go into the most recent climate change document that was put out by the 13 federal agencies, it all basically says the same thing. We are in line for more unpredictable weather overall. So more rainfall coming in bigger chunks with bigger drought spots in between it. On the coast, you're looking at more intense storms, maybe a greater number of storms, just more unpredictability overall. And you can talk to a lot of the more seasoned folks out there and ask them, hey, you know, my family's from Minnesota and I've asked my grandpa, I feel like we don't get as much snow as we used to, Grandpa. Is that accurate? He says, absolutely. When you were a little kid, there were 2, 3 feet every year. And then we always had that. And now we just don't get that. I mean, there's been Christmases up there where they haven't even had snow. So things are changing, and all these things are going to affect forestry, the forest ecosystem, and then also what we do as far as some of the fire activities. So going into fire, if you have a prescribed fire, if it's done right, there should be no mortality. Okay, a prescribed fire done under the appropriate conditions should just hum along top, take off what you're intending to take off as far as what gets burned, and everything should be fine. You contrast that with a wildfire, and you could have up to 100% mortality if those get going. And we've seen that with recent fires, both in the east and the west, where you get a complete ecosystem reset with a fire that gets out of hand, because it will burn up all the tall living trees. It will burn the trees that are in the understory, and it will be so hot on the ground that it will, can even kill some of the seeds and some of the regen. So you can get this complete ecosystem reset. The thing is, fire managers know how to manipulate fire to minimize these negative impacts. That's why it's important that if you are doing your own prescribed fire, take a training, get certified, work with one of the state folks that can help you put the right kind of fire out at the right time, and make sure you do that prescribed fire in an appropriate way. And when we talk about fire, there's a realm of fire. So it seems like it'd be easy to do a prescribed fire, but there's a lot of things that go into it. First of all, there's seasonality. So if this whole line is your entire year, from the get-go, there's only about half of it where you can actually try to burn effectively. Within that area, all these things, fuel moisture, wind speed, temperature, relative humidity, they've all got to line up just perfectly to get your actual prescription window. So when you start looking at all the time you've got in a year, the actual time you've got that you could do a burn becomes pretty short. So that's why it seems like every year there's this rush to try to burn what we can as quick as we can, because pretty soon that window is going to close and you're going to have the wrong temperature, the wrong speed, the wrong moisture, anything like that. So it's tricky to get all the fires in that we need to. Now, prescribed fire is nothing more than a tool. It's a management tool we have. It's a tool like thinning. It's a tool like herbicide. It's just a tool. But what this tool does is it uses the fuels on the floor to do the work. And the thing we want to do, we want that fire to do a thing, and that is generally control competition, reduce fuel loads, that type of thing. So what we prescribe is a fire behavior. So we're prescribing we want the fire to do on that particular day, on that particular stand. And there's a lot of things that impact this fire. The fuel type and load, the actual composition, the moisture of the fuel, humidity, temperature, wind speed, wind direction, all of these things impact fire behavior. And so behavior, if you remember, that is what we are trying to manipulate in the first place, so it can be tricky to get the fire to do exactly what you want it to with all these outside factors. But in the end, it's the fuel that drives all these fire effects. So on this line, I've got this dark line here. Over here is moisture of extinction. That is a fancy way to say standing water. So in standing water, you are probably not going to have anything burned down here. Over here with complete consumption, that is your catastrophic 100% killed wildfire, where all of these things burn. Somewhere in the middle of that is your prescription window, right? It's not standing water, it's not catastrophically dead. There's a window here, and within that window, each of these things burn a little differently. So it could still be fairly wet over here, but grass and pine litters might still burn. As it dries out a little more, you're going to start to see hardwood litter will light up, and that will start to burn. As it dries out more, you get some of the 10-hour fuels go. These are your twigs and sticks. Think of things about the size of your finger, the diameter of your finger, or a pencil, that type of stuff. And as it gets drier and drier, some of these other things start to burn. Some of these, the duff layer. And then once you get over here to where you have this 1,000-hour fuels, these are your logs, your down trees, your logs. By the time these are burning, it's starting to get pretty dry, and these may or may not be inside the prescription window. So all of this is to say, when you're doing a prescribed fire, you really got to think about what is on the ground and how it's going to interact with the fire as it goes over there. Now, there's a lot of things that go into this prescribed fire, and there's a lot of models that are out there that tell you, well, when should I burn? When should I burn? When should I not burn? Ben Hornsby said the other day something that I thought was really great. He said there's no amount of modeling that can make up for the supercomputer that is the human brain and experience. And people that have done this and experienced folks can go out there and they can assess all of these things and decide if it's worth burning on that day. And this is just an example. We've got two pictures here, basically the same type of land. One is a bright sunny day, one is a cloudy overcast day. Which is a better burn day? Well, this completely depends on what happened prior to this day. If you look at this picture over here on the left, if it had just rained 2 days ago, this might be good enough because that bright sunny day and a little breeze might just dry out the top enough to where it will carry a fire. On the other hand, if you look over here, and if it had just rained 2 days ago and you still got a cloudy, really cloudy overcast sky, you might not get anything to burn. Now that said, if it hadn't rained in a while and you had high humidity, this might be worth burning because it will then carry the fire a little better than if it was blazing hot and dry like it is over here. So taking into consideration the exact characteristics of the land you want to burn is very important. And we'll come back to this, but it's important not to make blanket management calls based on something on a regional scale. Just because there's a drought over a whole region or it was dry all last week, it's still important to go look at that exact tract that you want to burn and see on the ground if it will burn. Because there are certainly cases where even if you're in dry conditions, maybe you've got a pocket that's down in a lowland that will carry a fire that won't get out of hand because it's a little more moist. Fires need to be looked at on a case-by-case basis, and I think that's one of the important things we need to do is look at those fires on a case-by-case basis and not make these blanket recommendations. Now, what else goes into all this, of course, is bark beetles. So let's talk about bark beetles and how some of these native bark beetles we have in the Southeast factor into all this fire stuff. In the Southeastern US, we have 7 species of native bark beetles. There's 4 Ips species, there's 2 Turpentine beetles, and there's a southern pine beetle. One of these Ips, the Ips pinei, we find that really only in the Appalachians. So you might find it barely in the North Georgia, but then kind of going up in the upper elevations. And this one will go all the way up into the northern and western part of the US. Dendroctonus valens, the red turpentine beetle, similar. You will find this in the Appalachian Mountains, maybe North Georgia, but that's about as far south as it goes. And it also follows kind of Ips pinei's range, where it goes up into the northeast and out west. So by and large, in the southeastern US pine belt, we've got the southern pine beetle, we've got what we affectionately call the little Ips, the medium Ips, and the big Ips, and then we've got the black turpentine beetle. Now, much like the picture, one of these beetles is not like the other. And of course, I'm talking about the southern pine beetle. So this is a beetle that's different from Ips and different from turpentines. And just so we're all clear, this is not a cat. Okay, everybody? Super. So the southern pine beetle is native to North America and Central America. All those beetles I showed you are native to the US. So we're not talking about an invasive species here. We are talking about insects that have been here a long time, and are part of the ecosystem. The southern pine beetle is the one beetle we have in the Southeast that is capable of major outbreaks and capable of killing live, healthy trees. Okay, this is a picture of a southern pine beetle outbreak. It probably started right here in the middle where all these trees are gray and dead, and then it spreads out. It spreads out. And you can see over here on the edge, you've got trees that are just starting to fade and become yellow. These are the most recently attacked trees. Even some of these green trees are probably already attacked. They just don't know it yet. So green, yellow, red, brown is the progression. Southern pine beetle is one of these beetles that can create these great big outbreaks. Now we're going to talk about ips and contrast that with ips. So these are your 4 ips bark beetles here. They make galleries that look quite different, but these generally attack weakened or stressed trees, and that's important, weakened or stressed trees, and they can cause some mortality, but it's usually always during droughts or always in a situation where the trees in that stand have been compromised. Now go back real quick. Here again is a southern pine beetle damage. This is a southern pine beetle spot. You can see it starts in one spot and it radiates out and it makes a huge patch of dead trees. This is what ips damage looks like. You see we've got a dead tree here and a few dead trees here and here. Here's a little patch, there's a dead tree here, dead tree here, dead tree here. I tend to think of ips are sort of like the wolves of the forest. They are going around out there, they're always out there, always flying, and they are picking off the old and the weak. So an ips tree won't get into a healthy pine tree. It will get into a tree that is already damaged or weakened by some other factor. Maybe that factor is simply old age. Maybe that factor is construction damage in town. Maybe that factor is a lack of management or poor management. Any of these things that can weaken a tree can make it susceptible to ips bark beetles. And that's just how these things work. That is their ecological role, is to break down dying trees and help recycle them, basically. The black turpentine beetle, no, I don't have the red turpentine beetle here, but from a biology standpoint, it's very similar to the black turpentine beetle. These function very similar to ips in that they attack in weakened or stressed trees, and during droughts you can see some mortality. But again, these beetles are not going to be something you get in a healthy pine tree. They're just not strong enough. They're not aggressive enough. Ips are also not aggressive enough. And a healthy pine tree can generally either fend them off, or if they do happen to get in there, a healthy pine tree can live with 1 or 2 ips beetles in its bole for years and not see a problem. So when we get calls that someone says, ips bark beetles killed my tree, or I've got a turpentine beetle infestation in my tree, it's not because they suddenly became super aggressive. It's because something was wrong with that tree in the first place that caused it to be weak enough to be attacked by the bark beetles. And again, maybe that's drought, maybe it's mechanical, maybe it's just bad genetics in the tree. It could be any of those things coming together to make these things weak. So when we talk about the susceptibility of a tree to bark beetles, it's very different, or it's very important to differentiate. There's southern pine beetles and there's the ips and turpentine beetles. We are still not 100% sure what sets off southern pine beetles and makes them outbreak, but we do know that when they do outbreak, they will kill a healthy tree even if you've done everything right. That's just part of what they do. The ips and turpentines, on the other hand, they need a weakened tree to get in and get started. Now let's talk about how do we use these things to try to build resilience in your stand, in your forest. Resilient forests are those best prepared and able to withstand unplanned stressors. Okay, if we could plan for the stressors, that would be one thing, but in general terms, something that stresses your stand is not something you're prepared for, like a drought or a wildfire. You cannot prepare for those types of things. It's also very important to not be so focused on preventing damage to one tree that we put the entire forest or entire stand in jeopardy. And what we mean here is we need to manage forests, not trees. We need to make decisions on how to manage this whole land, whether that's a 5-acre swath, a 50-acre swath, or a 500-acre patch. We can't manage that based on what might happen to one individual tree. It's important to remember that sometimes trees die, and that's just a part of it. And when you're managing for a forest and you need to manage for this forest on a broad scale, you got to remember there's risks inherent in everything, right? Everything has risks. I took a risk today when I got in my pickup and I drove up here to the office. You take a risk if you eat a pack of chicken wings, right? A bone could get stuck in your throat. You could choke. Everything we do has risks, but we know how to minimize risks, right? In the case of driving, you get a driver's license and you follow the rules of the road, I hope. You don't speed, you use your blinker, you do all these standard driving things that make driving safer, even though there's risk to it. Chicken wings, I hope you don't eat so fast that you choke on bones, right? That's kind of what my mother taught me, is you eat slow enough to where you won't hurt yourself. And that's what we're trying to teach our kids. It's troubling at times, but we're trying. But there's risks in everything. And even if you grow southern pine, there's a risk of southern pine beetle. We know there is, but the difference here is that we know how to prevent those risks. We have the Southern Pine Beetle Prevention Program. This has been run by the U.S. Forest Service since 2003, arguably one of the more successful government forest health programs we have. I would say this and the gypsy moth program, Slow the Spread, are probably the two most effective programs we have. This program takes a proactive approach to managing southern pine beetle. And we've done all sorts of research. There's been a lot of people that have worked on this over the years. We know that by thinning and burning, we can reduce stand susceptibility to southern pine beetle. We know this. The SPB prevention program promotes this. And this is how we deal with the risk of southern pine beetle. We were even able to manage or to measure this on a large scale. We measured 910 spots in Mississippi a few years ago. That's this paper right here. And we found that on those spots, every single spot for southern pine beetle in the Bienville National Forest was on unthinned land, and all but 2 in the Homachito were on unthinned. So this is extremely strong evidence that, hey, if you thin your stand, it's going to be resistant to southern pine beetle. And we've even got that in picture form. Here's a chunk of land where the pine beetles flew through. Here's your thinned area right here. And then afterwards, the pine beetles came through, and that spot line directly follows the line that was thinned. Okay, so the beetles came this way, the spot started, and then the spot stopped right where we thinned. So we know thinning works. We also know that prescribed fire works as well. We were able to look at what are the impact of fire on this thing, as you know, on this study as well. And we found a few things. We found in every case, whether you looked, we looked at the stands that weren't thinned with southern pine beetle, the ones that were not burned had a much greater chance of having southern pine beetles. In all cases, this big black line, not burned, is the highest, because the places that were not burned had the greatest chance of having southern pine beetle. This is important because, southern pine beetle doesn't usually attack after a fire, but what a fire does is it opens up that understory, so that when a southern pine beetle does try to get established in there, the minute that beetle drills into that tree and puts out a pheromone that says I'm in and calls in its little buddies, if it's an open understory, the wind can take that pheromone away and a spot won't start. So it's a physical control on southern pine beetle by taking away the pheromone that attracts other pine beetles. So thinning, burning help reduce the chance of southern pine beetle. Likewise, if you grow pine, we know there is a risk of Ips and turpentine beetles. Pine is their host. That's what they do. Again, we know how to reduce these risks. Okay. For both of these things, you're after proper management. If you take care of your trees, keep them at the right stocking, burn them when they should be burned, thin them when they should be burned, you're probably going to be okay. Now, never say never in science. There's some extreme cases that'll happen where you will get some Ips damage. But again, these beetles are going to attack stressed trees. So if you get to a situation where you've got Ips damage or where you have turpentine beetle damage, that is because the trees are stressed. One example here, we had this in Mississippi a few years ago. They started seeing fairly large Ips spots. Normally we measure an Ips spot by the tree, or tens of tree stops. They had a really, really bad drought in the western part of the state, and they started seeing Ips spots. Now, I'm not sure if these were burned or not. There's not too much understory there, but at some point, there's just so much drought that an Ips spot is bound to happen, and that happens. That happens. So then a question we get is, doesn't burning cause tree stress? If you follow your prescription and do your burn properly, the stress to the tree is going to be minimal to none. Okay, now the key here being if the prescription was followed and the burn was done properly. And we've all seen or heard about fires that get out of hand. That doesn't fall into this category, right? If you are doing a burn and it gets out of hand or didn't follow properly or it didn't work, then yes, you could stress trees. But if you do a burn correctly, you're going to have minimal to no stress on those trees. So one of the things that has happened in the past is we've had some areas of dry weather, and there might be folks out there that say, you know, it's a bit dry, I just want to play it safe. I'll be conservative and I won't burn just to be on the safe side. You know, I think if you're trying to burn when it's an actual drought, I think that's going to be very difficult to do, simply because your prescription window is going to be so narrow. It could be next to impossible to even find a point where all your things line up. But then once it rains, once that stand changes and you could meet your prescription parameters, we want to make sure we don't let a past drought dictate what happens in the future, right? Because if you don't burn, the risks of not burning that stand far outweigh any potential fire damage. So, you know, one of the things we tend to see sometimes is fire gets treated as optional when for some of these systems, it's an essential thing. It's part of what the trees have evolved with. It is one of the main things we use to take care of the competition. We try to, you know, we don't like to see recommendations based on possible but avoidable stress related to fire damage. This gets back to having a good prescription, following that prescription, and having people out there burning that know what they're doing and know how to handle the fire. What often gets ignored is the actual stress from competition and the danger from accumulating fuels that can occur when you don't burn. Okay, so the delay in action results overall in a fire deficit, but when you look at the actual on the ground stuff, if you don't burn for one of your cycles, that is giving all that competition, all those other hardwoods, all those other forbs and vines and everything, a chance to grow and get a year bigger and get a year larger root system and build up some reserves. And we've got data that shows this is, you know, the tons per hectare of mass, live and dead fuel loads. On a 1-year burn cycle, it's pretty low. On a 2-year burn cycle, it's pretty low. But you start waiting 4 years between burns, it's starting to get up there a bit. And on unburned plots, there's all sorts of stuff out there. The point is, if you miss a couple fires, you can hit a tipping point in the stand that can be really, really hard to come out of. You know, over here on the left, you've got a lot of small sweet gum here. This is easily burned. You can get rid of this stuff. You can top kill it. You can sort of protect and keep managing that stand well. You get to something like this, and you've got all sorts of ladder fuels in there. You've got competition that might be getting too big to where it won't even top kill anymore. At that point, you've got all sorts of other stuff you are going to have to do. You're going to have to get in there with herbicides. You may have to come in with something mechanical to try to knock that stuff down so you can get a hold of it again. And it's a conversation we've had. Well, what do you do if you have a stand that has been neglected from fire for a long time? Let's say it changes hands, right? And all of a sudden it gets forgotten and then you get to a point, it hasn't been burned in 10 years. What do you do with it? Well, if you're not just gonna run a fire through there if it hasn't been burned in 10 years. You've got to come at it with a multi-step process to try to get it back under control. It's not going to be cheap and it's not going to be easy. So maintaining that burn cycle is really important for a lot of these stands because it prevents a lot of future problems going down the road. One thing a lot of people don't think about is how much water broadleaf trees use. Now, this is comparing sweet gum water use and loblolly pine water use. This is over a whole season. So this is your 12 months right here. Even though sweet gum drops its leaves in December and there's 4 months where it doesn't even have leaves, it still uses way more water than loblolly pine uses, even though it's alive and transpiring the whole year round. Sweet gum is an absolute water hog. So, you know, it may not look like a big deal if you've got a carpet of knee-high sweet gum seedlings or waist-high sweet gum seedlings on the bottom of your stand because you think, well, the pines are outgrowing it, they're overtopping it, we should be fine that way. The sweet gum is actually using quite a bit of water and causing quite a bit of water stress there. There's studies that have been shown that even when it gets dry, sweet gum keeps using water at a high rate because it just doesn't care. So loblolly might suffer because you've got sweet gum outcompeting it for all sorts of water. Sweet gum is just one example. There's, all the invasives, the privets, the honeysuckles, the vines, all these things. There's a reason these things are so prolific. And there's a reason weeds are weeds. There's a reason they reproduce the way they do. They're very efficient growers, very efficient spreaders, and very efficient at what they do. And they're great competitors when it comes to obtaining water and obtaining nutrients. And they can be a huge, huge detriment to the crop trees you're trying to have on there. So when you postpone fire, there are huge consequences for both tree stress and beetle dynamics. And it's a big circular loop here. So if you've got a stand that you decided not to burn, you're going to let that go another year, another two. You're going to have greater competition for the water and nutrients in that stand from the hardwoods, from the grasses, from the vines, from the mid and understory. This is going to inhibit the recovery of trees from any type of drought stress, because remember, those hardwoods are very good at getting that water. Even though they drop their leaves in the winter, they've sucked up so much water at that point that they've outdrank the pines on an annual basis. This just increases future drought stress for those trees too. More open stands reduce the southern pine beetle pheromone efficacy. We talked about that as well. So if you postpone that fire, you're creating a dense stand. And in a dense stand, air does not move very much. And if air does not move after a pine beetle has gotten in there, then that pheromone is just going to sit there and allow other pine beetles to come and get attracted. And that's how outbreaks start. When you've got one tree that gets attacked and other beetles can sense that pheromone and then they attack the ones around it, that's how it starts. So it's important to open those stands up. And if the mid-story gets too big, the fire's not going to top kill it. And we touched on that. You're going to have to come in there with some over-the-top herbicides or, hack and squirt stuff. Either way, you're looking at a whole nother step. It's going to take time. It's going to take money. And that's when it gets down to management, because your management becomes more costly and more difficult and more labor intensive because of missing some of those those burn intervals. And here's just an example. If you look carefully in here, you can see a pine tree. Here is one. There's one peeking out over there and over there. This is a stand that should have had some sort of competition control done to it. It clearly has not. So at this point, a stand like this is probably beyond burning because everything in there is as tall as the pines. If you run a fire through there, that whole thing is going to get burnt off. Because we waited to do any sort of management in here, now your only option is some sort of broadleaf herbicide. Start there. You're going to have to go there mechanically, try to knock that stuff down between the rows and find the rows of pines again. This stand is going to take a lot of resources and a lot of effort to try to get under control again. And these trees aren't that tall. I mean, I took this picture standing, on the side of the stand. This stuff is probably 7-8 feet high is all. So these trees are not that old, and you're already on the brink of losing that stand completely. Here's one that's a little bit older that had been, we talked about having sometimes a stand will fall through the cracks. Here's another one that fell through the cracks. This is a stand that was forgotten. It changed hands. It changed ownership. You can see we've got hardwoods in here, 5, 6, 7 inches DBH, big vines crawling up them. You've got a snapped off pine right here. Some of the other pine, looked extremely sketchy. We got called to this stand because they thought there was a thing called pine decline. It turns out it was nothing but, the stand was dying because it had been completely unmanaged. No fire, no herbicide, no competition control whatsoever. Just a completely overrun stand. And for something like this, there's not much you can do but try to harvest what you can out of there and start over. Okay, this stand has reached, it's beyond the point of saving, really, and that's what we ended up telling them. You try to get what you can. Some of these trees are still alive. Get those out of there and start over and try to get a management plan in place for that. So going back, we talk about, properly conducted prescribed fire is not going to stress trees. It's not going to bring in more ips or turpentine beetle damage. There are studies that show you will get a little pulse of ips and turpentine beetle captures after a fire, Some of that is they are going to some of that, the dead stuff that's killed, some of the stuff that's recently killed, but as far as actual damage in the stand, I can't think of any studies that show you get more damage, especially more long-term damage from IPS or turpentines after, again, properly conducted. This is your key word, properly conducted prescribed fire. But what that fire will do is that it's going to help control all that competing vegetation. It's going to promote your forest productivity and promote forest health and resilience. And it's going to make that stand more resistant and resilient in the face of future bark beetle issues and future drought issues. I think we need to understand that we are going to keep having droughts. You know, obviously this year was a pretty wet year for most of us, but it can turn on a dime and we could easily be in a drought situation this spring. Stands that are well managed, stands that have a very low amount of competing vegetation for the crop trees, those are going to be the ones that make it out of droughts the best, and those are going to be the ones that do not get attacked by bark beetles. Again, the IPS beetles and the turpentine beetles, they are going after stressed trees. So if you've got something that's overstocked, if you've got a stand where there's a lot of competition for water, for nutrients, that is going to stress trees. That is going to bring in the IPS and turpentine beetles. So in a lot of these ecosystems, especially these pine ecosystems, you know, fire shouldn't be looked at as an option. This is a management tool that these ecosystems desire. Okay, you know, there's big risks to not burning. We talked about all the competition, all that type of thing. And I think it's important that we understand that inaction is a decision, right? So we can decide to not burn. If there are legitimate reasons for not burning, then that's fine. That's a good decision. But if there's no reason other than we think it might be dry without actually checking on the ground and seeing if you could meet your prescription parameters, you know, there's consequences to these decisions. And the main consequence is you're going to get more competition, more understory, more mid-story growth. That's going to put more stress on the trees you leave, especially pine crop trees. And if you've got stressed pine crop trees, that's when you can get the IPS and the turpentine beetles. And it all goes back to that thinking of, you know, everything has risks. Is it more worth burning or not burning? You know, if you don't burn, there are risks. I think sometimes we forget that if you don't burn, there's still risks because you're going to stress those trees just in different ways and a year later. We are currently working on a fact sheet on this very topic. And in it, we've got what we think is a pretty slick figure, kind of talking about if you've got a stressed, unhealthy stand versus a well-managed stand. You know, we know that if you thin and burn your pine stands, you're going to have less southern pine beetle and less IPS outbreaks. We know this. There's been a lot of smart people done a lot of research on this. We even know that if a drought hits and you have a stand that has been thinned and burned and is well managed, it's going to be more resilient to drought, because even though it's a drought and there's less water, the trees that are going to be there are going to be stronger and better able to handle that drought and reach some of the water that might be there. Hardwoods use a lot of water, and that's something we got to remember, especially sweet gum. It is an absolute water hog. It sucks up the water fast. It sucks it up for a long time, and over the course of a year, it's going to suck up a lot more water than a pine is, even though it drops its needles for 4 months of the year. We need to remember that it is, you know, it's a water hog, and with that, it's a nutrient hog too. Most fires are going to have very little impact on mature pines, and occasionally you will get some scorch, but pine trees are incredibly resilient. I've seen them flush back from a lot of scorch, and you know, we've Doug Aubrey's on here, he can speak to that as well, but pines can handle scorch. I hope if you're doing your burn right, you're not getting scorch, but even if it does happen, that doesn't mean your pine is going to die, and it doesn't mean that you're automatically going to get bark beetles. Now, if you do get things a little hot, you could get some in there, and that's why it's important to follow the prescription and go at it like the prescription requires. And then overall, especially, you know, throughout the southeastern U.S., the vast majority of our beetle spots are going to be in unmanaged stands, and that includes southern pine beetle, that includes IPS bark beetles, that includes black turpentine beetles. Unmanaged stands are where you are going to have the most beetle damage, because unmanaged stands are basically stress stands. And most of these things, like tree stress, it's what brings them in. It's what they can feed on, and that's where you get the beetle spots starting. So with that, I would like to thank everyone. And, this funding was provided by the Southeast Regional Climate Hub for this whole project. Thank you. And I think all of us here on the panel would be happy to answer some questions.
All right. Hey, thanks, Dave. Once again, if you joined us during the presentation, my name is David Godwin, and I'm the coordinator for the Southern Fire Exchange. We just had a great presentation by Dr. Dave Coyle from Clemson University, and we are joined today by a bunch of his collaborators for the Q&A period. We have Dr. Joe O'Brien, Dr. Doug Aubrey, and Leslie Bobby. So we've got a great panel. Hope you guys have some good questions. At this point, you can go ahead and start typing them into the Q&A section, and we will go ahead and field them. If you can't get the Q&A to work, you can go ahead and write your questions in the chat, and we'll get to those right now. All right, Dave, I'm going to pull up. Let's see, you still got your thing there. Stand by.
Stop sharing.
Actually, we'll go ahead and leave yours up, and then if you had any slides that you want to bump back to or refer to, you can do that at this time if that works out. So over here to the Q&A, see if we have any questions that come in. All right, not yet, but I'll go ahead and give folks a moment to type those in. So I had a question and see if I can get some feedback from you and from your partners here. You talked about managing scorch as one of the strategies for reducing the amount of stress that trees have from the prescribed fire. Can you or anybody else talk about strategies for reducing scorch on prescribed fires?
Yeah, I could
Doug,
jump in.
or Joe, yeah.
Yeah, great job, Dave. That was a great presentation. Remember that a prescription is tailored to an individual stand, right? It's just like your doctor when you're sick with some illness, he writes a prescription tailored to the condition that you're in. So, a prescription is this guideline for you to get the desired outcome from your fire. So if one of your desired outcomes is minimizing scorch, you have to examine the stand, of course. And what Dave brought out about stand ventilation and southern pine beetle pheromones, that applies to scorch as well. A thin, relatively open stand can ventilate a lot easier. So you often can get rid of the hot gases that would cause scorch, and there's a lot more mixing and cooling of the fire atmosphere if you've got a more open canopy. That said, tailoring your fire energy release, which is what we're trying to do with our prescription, is based on weather conditions, fuel moisture, fuel loading, and then ignition pattern. So there are ways you can manipulate your ignition pattern such that you minimize sort of that lofting of hot gases that will cause scorch. So sometimes it's counterintuitive. It's going to be based on terrain. It's going to be based on fuels, but often you want a faster moving head fire rather than a slower moving sort of flanking mixed heavy ignition pattern where the plume is going to develop and go straight up rather than kind of moving forward and mixing a lot. So it's kind of like an individual case by case basis. In general, moderating your fire behavior will minimize scorch. And that's something that, you learn through experience, and it's based on your ignition technique, weather conditions, and your fuel of your stand, plus the fuel conditions itself. So there's no one answer to that question. It's kind of a weak answer, I feel like, but you can do it. And just to reiterate, and Dave and Doug can jump in on this too, is these trees, they're adapted to frequent fire through, all their evolutionary history and through thousands and thousands of years of human burning. These things can take fire. And even if you do scorch them, it's not a guaranteed stressor. And Doug, do you want to jump in on that?
Sure, yeah. The, pines, longleaf pine in particular, but really all the pines, slash and loblolly here in the Southeast, they have a large kind of capacitor to deal with the loss of those ephemeral tissues, of those leaves. So once they get burned or scorched, immediately after that happens, they start rebuilding that tissue using carbon that they store below ground in their root system. So we've, thinking of their physiological activity, we've seen that after scorching a canopy nearly 100% in longleaf, they recover, and within about a month, they're transpiring about as much water as unscorched trees that they're compared to. So they recover very rapidly and have a lot of resilience in this. They have a bank account essentially of storage because they're in a system that quite frequently they have to draw upon that.
All right, we have some questions that are starting to come in, and I'd like to get through some of these. Here's one that came in from Casey, and they said that they had a wind stress event from Hurricane Irma, and then they had beetles, and then unexpected mortality from a prescribed fire. Do you know how long one should wait after a wind stress event before burning? If you've already have beetles, should you still burn but use milder conditions? So I think this is pretty relevant to a lot of folks in Southwest Georgia and North Florida right now. What do you guys say about sort of other disturbances and stressing the trees, particular wind events, in combination with prescribed fire?
I can go first. When it comes to the beetle thing, especially Ips, bark beetles will get into down trees. So they can, southern pine beetle, not really, turpentine beetle, not really, but Ips can survive in a tree that, bends over or snaps off, at least until it completely dries out. It sounds like what a lot of places down in, Southwest Georgia experience is a really bad situation and group of circumstances. So how long do you wait to burn? I am of the cloth that you might as well do it sooner rather than later and try to get that stand under control again. I don't think you're going to be able to avoid Ips problems in a situation like that because there's so much stressed host material. And, even the pines that didn't break off in the wind, I'm assuming with as much bending as they took, there's probably stress on there that we can't see, and those Ips will get in that. So, that's one of those things we don't have a lot of data on. How long should you wait after a windstorm to burn, and what are the impacts going to be? We really don't know, and that just comes down to, guesswork by people that work with beetles and people that do fires to try to figure out, what's the best strategy. And just, really quick, I do think that forest health people and fire ecologists and tree physiologists probably should be talking to each other more than we currently do. We each tend to get in our little silos, and I think for an issue like this that cuts across all those boundaries, it's really beneficial to talk to these other people. I mean, I know I've got a good handle on the forest health stuff, but I've learned a ton talking to Joe and Doug and Ben and Leslie about the fire stuff too. And, I wish I had done this earlier in my career so I could use some of those things. But getting back to the point of what do you do in a stand that's been, wind stress like that, that's a tough one. And it just comes down to, how many trees are down, what sort of fuels do you have down there, what are the Ips populations like? All those things are going to determine whether or not you should burn. I know Joe said he danced around one. I feel like I danced around that one pretty well too, but it's a tricky one.
I'll second what Dave said. And even sort of an anecdotal observation of, we had unexpected mortality after a prescribed fire in a wind stress stand. Like, unless you did a controlled experiment where you didn't burn half the stand and burn half the stand, would those trees have died anyways? So was the fire really the causal agent of the mortality? So going back to what we know, that fire is going to knock back the release competition when the canopies opened up, there's research on that. And now you're dealing with a whole, like Dave said, you got a whole new set of circumstances. So you've got all this fuel on the ground, you've got heavies on the ground, you've got a very different situation that you're going to have to deal with. So when you tailor your prescription, you're probably also trying to manage fuels as well. And in some cases, it may be hard to get a fire to carry out across a stand where there's a lot of down heavy fuel, because the fuel moisture is going to be so high in a lot of these things that they're actually going to act as little mini fire breaks. So it's going to be a case-by-case basis. You're right, there's not a lot of great information. We do have this concept that we refer back to called the ecology of fuels, and we know that there's this really tight connection between overstory structure, distribution of fine fuels and how fire behaves. You disrupt that overstory, you disrupt the fuels. And so now you're in kind of like a response mode. How am I going to keep fire in the stand? How am I going to keep from letting the fire sensitive species from being released? So it's a tough situation, and a lot of times it's going to require some ad hoc experimentation on the part of the manager. But
Yeah.
I still think fire is going to be critical.
And storms in general are really hard from a forestry standpoint, especially a forest health one, because if the tree isn't snapped, and I'm talking windstorms, I'm talking flooding, ice storms, any of those things, you can't just see how much damage those trees took. You know, they may have bent and swayed, and they may look like they're still standing straight, but it's tough to know how much, you know, internal tearing happened, internal tissue damage happened. We don't know that, but the insects can tell, and that's why they're going there first. So it's really hard in situations like that to really know how much damage those trees took on from the wind or from the flooding. You know, where's the stress tipping point? That's the magic question we're always after.
So here's a question kind of jumping ahead, and it comes in, they're asking about returning fire into stands that have already had southern pine beetle attacks. And the question is, do you remove the trees, or do you burn the trees, burn the site while the trees are still standing, or do you pile burn? And then how long do you wait to avoid additional stressors if you're not gonna go ahead and total out the stand and start again?
Well, from a pine beetle perspective, you know, fire isn't going to bring them in. If they're in, the first thing you want to do, I assume they mean if the southern pine beetle outbreak is still going, because if it's still going, you want to cut around that thing and try to stop the outbreak first. So you want to go to the edge of your southern pine beetle infestation, you know, find the trees at the very edge. They're probably not even yellow yet. They're going to be green. And what we do is we cut a swath of green trees, whatever the height is of that outside tree. Let's say the furthest out tree that's impacted is 50 feet tall. You want to cut then a 75-foot buffer of green trees outside the spot. Cut that out. Hopefully you can sell those, get those taken away. And if you're lucky, you can get some of the salvage cut done and get some of that out of there. So the best case scenario is you get all of that stuff out of there as much as possible, and then just start again with your burn regime. I don't think you stop burning because of southern pine beetle. What we do for SPB is we cut the spot out. If you can't sell the timber, you know, you cut it and fell it in towards the middle of the spot. Then you're going to get in a situation just like Joe said, where if you've got all sorts of this big stuff down there, I'm not sure that a fire is going to go, you know, through the damaged part very well. But I would say with the rest of it, you burn it as normal, because you want to make sure that stand stays open and try to prevent future things from happening there as well.
All right, we're coming up to the top of the hour, so I think we have about one more time for one more question. And I'm going to go to this one, which was, any thoughts on the season of burn and the risk of beetle attacks? Are there any relationships there?
You know, I don't think so. I think, you know, we're going to get less beetle pressure over winter because they tend to, you know, slow down their populations. But they're, you know, the IPs especially aren't looking at the season. They're looking at the overall stress. So I don't think it matters when you do a burn. If you're doing it the right way and the trees are not getting stressed, you're not going to increase the chances for beetles. So it all comes down to doing that burn the right way. And if you do it the right way, you should be in good shape. Would you say, Joe?
Yeah, I agree. And you know, once again, the main impact of season of burn, there's two impacts. One would be the phenology of the tree, what's going on with its phenology. I saw somebody had asked a question about candling, you know, and yeah, perhaps now that apical bud is now more exposed and could be damaged more easily by a hotter fire, the air temperature is generally going to be much higher, so your tissues are already closer to that point where they're going to be damaged by additional heat generated by the fire. But, you know, in general, I would say, like, you have to think about how the fire is going to interact with the ambient conditions, and then separately think about what you know about the physiology and phenology of the tree. And, you know, once again, the science is lagging behind the needs. There's not that many of us who do fire research And so unfortunately, I can't send you to a particular paper, but a lot of this is going to be sort of adaptive management and observing whether you get desirable results or not, and thinking about how to moderate your fire behavior when the conditions become a little bit more extreme, which they often will do as you get into the growing season.
All right. Well, thanks, everyone. It looks like we've come up to the end of our time for today. So thanks especially Dr. Dave Coyle for your presentation today. And thanks Dr. Joe O'Brien and Dr. Doug Aubrey and Leslie Bobby. Thank you guys for joining us for the Q&A at the end today. If you would like to apply for SAF CFE credit for participating, you can see that link on the screen. We had one person say that they had difficulty with that link, so we pasted another link in the chat window, and you can click to fill that out to provide your information to be eligible for 1 hour CFE credit for joining us today. And if you have any issues with that, you can shoot me an email at d.godwin@southernfireexchange.org. And finally, as we close out the webinar, we do ask that you please take just a minute to fill out a 5-question questionnaire that gives some feedback for our speakers and panelists to let you know what you thought about the presentation today, and let us at the Southern Fire Exchange know how we can tailor our future fire science webinars to meet your management and prescribed fire needs. Like we said at the start, today's webinar was recorded, and we'll have the recording on our Southern Fire Exchange YouTube channel in a couple of weeks. So thanks again to our speakers. Thanks everybody for joining us today, and hope you guys have great holidays and New Year, and we'll see you in January. Thanks.
Yeah, thanks, David. Thanks for all the participants.
Thanks, everybody. Thanks, David.